Hello and welcome. My name is Ingrid Donnelly, Continuing Education Product Manager with IEEE. IEEE is the world's largest technical professional organization dedicated to advancing technology for the benefit of humanity. Before we begin, please note a few housekeeping items. At the bottom of your screen are engagement tools. You can use these tools to resize and move to optimize your space. Note that we recommend using a wired internet connection to access today's presentation and closing any programs or browser sessions running in the background that could cause issues. There is no dial-in number for this event. Please make sure your computer speakers or headset are turned on and the volume is up so that you can hear our presenters. You can find additional answers to common technical issues in the orange question mark help tool at the bottom of your screen. If you have questions for today's presenters, you can submit them through the Q&A widget on your screen, or click the purple Q&A icon at the bottom of your screen. We will answer as many questions as time allows. If you click the green resources icon at the bottom of your screen, you'll find more information about today's event and future events. Finally, the on-demand link for today's event will be emailed to all registrants approximately 2 hours after today's session. Our virtual event today is Discover Techniques and the End-to-End System of 5G Networks. The virtual event will provide an overview of the 5G Network's cutting-edge course program produced in cooperation with Nokia and IEEE Future Networks. Learners will receive an in-depth view of performance requirements, future scenarios, and the roadmap to implementation. With over 10 hours of content, this program also explores the intricacies of 5G standardization by the Third Generation Partnership Project, 3GPP, and the IEEE 802 LAN-MAN Standards Committee. Our presenters are Olivier Ayoun, Learning Manager, Laurent Lapierre, Learning Specialist, both with Nokia, and Dorothy Stanley, IEEE 802.11 Working Group Chair. If you would like to tweet about this event, please use the hashtag IEEELearn. At this time, I'd like to hand it over to Olivier and Laurent.
Thank you very much, Ingrid. So my name is Olivier Ayoun, and indeed I work at Nokia EDU, so the education organization of Nokia. And there I work on 3G, 4G, 5G learning, so for our customers and employees. So I'm very pleased today to be with you and for sharing some insight of the 5G learning modules that we have built with you and for you IEEE members. So what are the drivers for 5G? What are the drivers for introducing a new generation of mobile technology? And here, let me share a personal anecdote coming from 20 years ago. In 2000, I was personally a trainer on wideband CDMA technology, so what we used to call 3G technology. And I traveled across the world, so let's mostly Europe and Asia, delivering training on this new technology. And all along the various class deliveries I made came this question always, but why do we need 3G? Is that for watching TV on my mobile? It will never fly. So if we looked at 20 years later, it looks obvious that 3G and now 4G have deeply get into our daily lives. But what about 5G? So how will it impact our businesses? The main drivers for 5G are about industry. Think about manufacturing with dynamic production. Think about transportation with dynamic platooning. Think about healthcare and remote surgery. Think about immersive devices with augmented reality, public safety with proactive threat recognition, about mining, power industry. So the power of 5G is about enabling the industrial automation. So what is 5G and what are the technical enablers for enabling these industrial automation? 5G is built upon three main pillars. The first one that we used to call EMBB for enhanced mobile broadband is about increasing the throughput. So and being capable to reach up to 10 gigabits per second. So and is close to the fiber optical capabilities. So this is the main pillar for 5G. So more throughput, EMBB. The second pillar is about ultra reliability and low latency communication, what we used to call URLLC. So, which means two things. One is to enable the low latency in the network, so the low responsiveness of the network. And the second is this ultra reliability, so that you are sure that the network is capable to be there and to enable the communication. So these are essential for the use cases that we want to enable. The third pillar is about massive connectivity. So what we called massive machine type communication, MMTC, in order to enable the massive internet IoT for enabling these use cases. If we compare that to 4G, we will enhance the capability in mobile broadband, machine communication, and IoT numbers. So let me hand over to Laurent, who will bring you with more insight on the 5G end-to-end architecture, the spectrum we use, the massive MIMO, the multi-connectivity, the 5G core principles, and what you all have heard about network slicing. Handing over to you, Laurent.
Thank you, Olivier. So, welcome. Hello to all. My name is Laurent Lapierre. I'm also in Nokia Edu, part of Olivier's team in Nokia Lannion, France. And I will talk about the architecture and the key pillars of 5G. 5G is mainly standardized by 3GPP. And 5G will be introduced in our networks with different options step by step. And if you look at the literature, you will probably heard about the 3GPP option 1, which is in fact not 5G, which is only for information, the current 4G networks. So 4G network means radio LTE, long-term evolution, and 4G core, which is EPC, Evolved Packet Core. Currently, the 5G networks that are deployed in US, in Asia, mainly in South Korea, for example, or US or Japan, are all compliant to 3GPP option 3X, which means we add a new radio access type, 5G new radio, but we keep the anchor for the user plane at the LTE 4G level, and we keep the enhanced packet core, so we keep the 4G core. That's a 5G non-standalone option 3X. And thanks to that, we address mainly eMBB, if you compare to the last slide presented by Olivier. And the final and target option is a full 5G network, which would be standalone, so a single radio access type, 5G new radio, with a 5G core. We will introduce 5G core a bit later, but just at this moment, keep in mind that the full benefit of 5G, including URLLC and full benefit of eMBP and MMTC, are achieved only with a 5G core network. And currently, all networks are in option 3X, just because the standard 3X has been available a few months before option 2, and it would be possible for new networks to start with option 2 for very specific use cases, but not for use cases of current smartphones, for main user equipment devices, which are all compatible with option 3X now. And the path to option 2 will not be a direct path. Currently, as I said, all networks are in option 3X. But in fact, we've got 3 options, and in fact more, because here we simplify only with the main 3GPP options that are 5G non-standalone. The target is really the option 2, and it will happen for most networks only in a few years. In between, most likely, operators will evolve to a 5G core, introducing a 5G core, but keeping 4G and 5G for both access networks, and keeping the user plane anchor as evolved LTE. The next evolution will be to move the control plane anchor to the new 5G new radio. And probably it will be all 5G RAN only after a few years, because we need to refarm and replan the current LTE spectrum, which is expected to happen only in the coming years. That's for the 5G architecture options. Now that's important to browse the key pillars of the differentiating 5G technologies, that are all the underlying technologies that makes possible the gap in requirements between the 2 triangles that were presented before. The first differentiating technology is the spectrum. In fact, 4G spectrum is currently all in the sub-6 GHz spectrum. And if you compare the 4G spectrum to what we could have in 5G new radio, you've got a large millimeter wave bandwidth opportunity for 5G new radio. So in fact, the capacity and spectrum and capacity gain we've got in 5G for bandwidth and throughput is partially achieved with better radio techniques, and partially achieved with much more bandwidth, especially in the millimeter waves above 24 GHz. So the bandwidth opportunity is globally from 24 GHz to 100 GHz, but 3GPP has currently decided to introduce 2 new frequency range, one with full sub-6, so much more than the 2 or 3 gigahertz we've got for 3G and 5G, and another one in named frequency range 2, from 24 gigahertz to 52 gigahertz. This one is really specific because that's very high bandwidth, very high capacity, but you need in practical to be in line of sight. So you cannot achieve very good propagation indoor. So you will need combination of both for a good network. Here you've got also link between the cell size, typically macro, microcell, small cells, and small cells for frequency range 2. Pay attention to the fact that this link is not so strict. Yes, macro cells is almost reserved to the sub-6 gigahertz. But large cells are theoretically possible above sub-6. In practice, you are limited by the need of being in line of sight. But small cells could also be done with sub-6 bands, and that's also what will happen in the real life. Now, a bit more in detail. Let's look at the progress we do in efficiency and spectrum efficiency since 2G. First, we have introduced transmit diversity. Basically, you can send the same signal to 2 antennas distant by a few centimeters or a few decimeters. And they will use different paths. And you can combine what you receive for better transmitting. When it's done both ways, you've got multiple in, multiple out. When you extend multiple in, multiple out with at least 8 antennas, with here the example of 16, you've got massive MIMO. When massive MIMO is used with a large panel, it's enabled what is called massive antenna array. And it is important to understand that massive MIMO and massive antenna array are new antenna techniques that are introduced in 4G and 5G, and the ones that are introduced in 5G will be backported also to 4G. Thanks to massive antenna array, you can create 3D beamformings that are small beams into all directions. And thanks to that, you can also create the ultimate efficiency in spectrum, which is multi-user MIMO, where 2 beams, for example, here beam 1 and beam 3, could use exactly the same carriers, exactly the same spectrum. So you could reuse even inside the same antenna set of massive array antenna, the same spectrum. So which is really efficient and can increase from a range of 3 up to 10 factor the spectrum efficiency. On top of this, you've got also what we call multi-connectivity or carrier aggression or multi-RAT, which is basically carrier aggression. You can combine carrier with 4G and 5G and inside 5G or inside 4G. If you combine carriers in 5G and 4G, you get what is named multi-RAT, multi-radio access type, or ENDC, EU-TRAN, new radio dual connectivity. You can also do multi-connectivity inside 5G on 2 antennas. And you can also do multi-connectivity with Wi-Fi or with other techniques. All in all, the target of all that is more capacity and improve reliability. So it's for eMBB and for UR LLC as well. The core in 5G is new, and I have to say not completely new. Many functions and principles of 4G EPC remains valid, and most principles of EPC remains valid. But some functions have their name changed, and some are also new. There are also 4 or 5 principles that are very useful. First, CUPS, control and user plane separation, with a real clear split between control and user plane, and the possibility to have much more 5G core, which is cloud-based. And one target of this is to have a localized user plane traffic near the antenna in edge cloud, and application is in edge cloud. And only doing this, you can achieve 1 millisecond ultra low latency in the second part of the triangle that was given before. You've got also the service-based architecture, which is a common network connectivity, not anymore diameter-based, but HTTP2-based connectivity, and which is very good to open the service-based architecture to new services in the future. Also, 5G core will be multi-access, 5G, 4G, and also fixed access. Not presented here, but it's also a core network that is a converged core network, including for the fixed in the future, starting 3GPP release 16 and 17. While some functions are very similar to 4G EPC, for example, UPF, IMF, SMF, which are very similar to serving gateway and packet gateway. Some of them are new, like the network repository function, the network exposure function, which is linked to service-based network connectivity and third-party applications, and the security edge protection proxy, which standardize the security and act as a non-transparent proxy for the roaming partners and for the home PLMNs and visited PLMNs. And others are new, such as the network slice selection function, which, along with new procedure in access and core, unlock the full possibility of network slicing. So all of this is a quite brand new architecture, and that's why the full benefits of 5G will be achieved only with a 5G network, typically option 2, or other option that includes 5G core and not only the EPC core. Coming back to why we need slicing, in this diagram you see 4G, 4.5G that really represents the 5G option 3X with EPC, and 5G phase 1, which is 3GPP R15 with 5G core, so 5G option 2. Thanks to that, you can reach some requirements that were not reachable before, with very low latency up to 1 millisecond, with ultra-high throughput, which was not possible before. And what is important in this slide is how various are the requirements. And maybe not presented here, also some requirements that are really different from that are from MMTC, with massive number of devices, good reliability, but low latency, low throughput, and sometimes capable to wait a lot before accessing to the network. So with good reliability, but quality of service that are really not the same, and priority that is really not the same on the network. And this is also achievable with network slicing, which is the fact that you partition your common network infrastructure into multiple logical end-to-end virtual networks instances to provide customized virtual private services. And you can create first, I would say, horizontal slicing with, for example, slicing that are dedicated to some services: voice, energy, transportation, manufacturing. This is what you do currently with most 4G networks, with voice, internet, and why not a few specific services like BlackBerry or public safety. But with 5G, you will be able to do the same, to connect humans and machines, and also to segregate all your large networks slices with different end users applications to sell them to very specific customers, and to have finally in the network not only a few dozen of slices, but really you could reach hundreds or thousands of slicing. And also the different slices must reach all parts of your networks, not only the access radio part, but also transport, core, and application. And all of this will require an end-to-end orchestration, because it's not possible manually to manage access, transport, and core, given the complexity of your network, and also given the complexity of your cloud-native core and all the different applications you will have for your different customers in and different verticals in the different data centers you've got. And this is also something that is very new with 5G, and that will be introduced in the coming months and coming years, because introduce 5G is not only a question of 2020, but a question of the next following years. So I think we'll take the questions at the end of this presentation, and I can hand over to you now, Ingrid, for the next slide.
Thank you, Laurent. At this time, we're going to pass it over to Dorothy Stanley. Thank you.
Hello, this is Dorothy Stanley. I am currently the IEEE 802.11 Working Group Chair, and I'm delighted to give you an overview here of the modules within that IEEE has put together along with Nokia, and which describe the IEEE 802.11 components as part of 5G systems. So why are we talking about this? We're talking about this because today IEEE 802.11 Wi-Fi systems are now and will continue to be an important part of carrier future. Today, 3 and 4G networks include .11 technologies for two primary purposes: for Wi-Fi calling and for offload. Various statistics, depending on the country, show that Wi-Fi systems carry most public and private internet traffic worldwide. Laurent described the 5G architecture in terms of the core network provide a means whereby radio technologies defined by 3GPP and radio technologies that are non-3GPP technologies can natively to the 5G. So the slides here give you some data from the Cisco VNI published in 2019 on the amount of data that is offloaded and carried on by Wi-Fi systems from cellular traffic. From 2017 to 2019. And then the chart on the right shows mobile and offload traffic projected now and in the future by generation of cellular technology. So you can see that the traffic offload continues to be extremely significant. In today's systems, specifically Release 15, a technology agnostic interface is defined for non-3GPP RAN systems, such as Wi-Fi or 802.11 systems, to interface into the cellular network. In the resource material that you'll receive with this that describes the Release 16 extensions, which adds support for trusted wireless LAN access in addition to Release 15 capabilities. So the slide you see here with Release 15 shows that the mechanisms left include discovery and authentication mechanisms using Extensible Authentication Program, or EAP methods, which are defined by the IETF. And these mechanisms are also included in Release 16. The goal being that the services that are provided to the end devices are accessible to users, whether they're entering that core network on a licensed system or an unlicensed system, such as .11. Okay. My intent is to give a brief overview of the modules that are included in the course that is being offered here. And there are three topics that are covered from a .11 perspective. One is the radio standards evolution. The second is technology concepts specifically related to two 802.11 amendments or standards, 11AX, also known as Y. And then the third module focuses on use cases. So here we'll talk about how 802.11 technologies can be used to support the advanced use cases, which you heard described by Olivier, including indoor hotspot and dense urban. So, but also in Internet of Things, IoT applications, and the low latency applications can also be supported. In addition, fixed wireless access and backhaul are supported by products that are available today in 60 gigahertz with extensions coming, and also very high throughput use cases are supported today. So focusing on IEEE 802.11ax systems or Wi-Fi 6 systems, the use cases, 5G use cases that are supported by this technology include high density indoor, of course, and outdoor, and low latency. So the standard supports rates up to 20 gigabits per second using available in the market. not at the 20 gigabits per second rate, but at substantial gigabit per second rates. You see that the use cases targeted by 11AX and how they map to the 5G use cases that have been identified. Focusing on indoor hotspot, or some data showing how Wi-Fi systems are supporting the hotspot application today. The data provided here is for the past several years of Super Bowl events, just to give a data point of the amount of traffic that can be by these systems. So you see that at the 2020 Super Bowl, you had 26 terabytes of data being transferred within a small number of hours during the event. The references are here where you can read more details. Okay. So in addition, working group for a self-analysis, simulation, and analytical analysis using the 5G IMT 2020 defined methodology for self-evaluation to evaluate the 11AX, MAC, and PHY against the 5G spot and the dense urban test environments. So you see here the various parameters that are defined by the IMT 2020 test environment, and such as peak data rate, spectral efficiency, etc. And the result of the analysis shows that exceed the requirements for both of these use cases, dense urban and indoor hotspot. The specific example shown on this slide is for indoor hotspot. Okay, so the previous slides focused on 11AX or Wi-Fi 6 and really relevance to the 5G use cases. The other standard I'll highlight here is 11AY, which is extensions for 60 gigahertz operation, specifically for wireless backhaul. So this is defined in license-exempt bands above 45 gigabits per second, and the standard is expected. The chipsets have been announced. You can see the list of use cases that are supported by the technology, and then how these map to the use cases that have been identified for 5G. So at a high level, the bottom line here is that, you know, operators use many different technologies in their networks and in bringing services to customers. And Wi-Fi 6, 11AX systems, and potentially 11AY systems in the future offer another avenue or additional option to use to meet end customer needs in for the set of 5G use cases. Specific example shown here is for 60 gigahertz fixed wireless. There are deployments today. Here you see the link, a couple of links provided, where 60 gigahertz technology that's in the market today is being used for fixed wireless applications. Okay, so as a summary, and then I have a couple of closing comments. 802.11 defined technologies provide radio technology components, and I want to focus on the radio technology piece to meet the 5G use cases and really support the comprehensive 5G service vision. The core, if you think about the 5G evolution, there are two pieces that were highlighted. There's the RAN evolution, and then there's the core evolution. And really, the core evolution is extremely significant. And interfacing an additional radio technology to that core network, which is the essential piece of providing all of this additional functionality, flexibility, and service offerings, is an important capability. So just as today, .11 components are an important part of carrier networks and deployments, they are positioned to continue to be. 11AX technologies, which include OFDMA, multi-user MIMO, support the requirements of 5G use cases, and the two that I highlighted were indoor. And then 11AY, which is a 60 gigahertz standard, looking at very high throughput operation in the millimeter wave bands, introduces additional technologies, including MIMO and channel aggregation, and this is to support very high throughput and fixed wireless use cases. The chart on the right, 3GPP architecture where you have an end device, such as a .11 device, interfacing to the core network. So at this point, I'll hand back over to you, Ingrid, to summarize the course and then take questions.
Okay, great. Thank you so much, Dorothy. So here we just wanted to go over, show you an overview of the 5G course networks, 5G networks course program. So there are three courses included in the course program, 5G system overview here, and these are all of the modules within the course. 5G core network principles, same, as well as 5G new radio principles. Then we also integrated in each of the three course programs, we also have the IEEE 802 portion that was listed below. This is just additional information on the course program itself, as well as how to access the course program. And now at this time, we're going to take some questions. Please just make a note that we'll get to as many questions as time allows. So one of the first questions that I did want to ask, and this would be for just overall about the course program. So the question is, I'm interested in the e-learning courses. Should I take all three courses or only one of them?
I think I can answer this one. In fact, there are three courses, yes, but the three courses cover the same, should cover the same content, not with the same depth. If you've got only 1 hour and a half, then you take Discover 5G. If you have 3 hours or 4 hours to dedicate to learning, you take 5G system principles. And if you have 6 hours or a bit more, then you can take the full course, Understand 5G system fundamentals. In the previous slide, what we've got there is the content of the last course, which is okay. which is the most comprehensive one. So this is what you will get with the last course, the most comprehensive one with 6 hours duration.
Okay, thank you. So we're going to take another question. Another question is, 5G is multi-radio access. Which technologies, 4G or 5G only, or other technologies may be used?
So not only 5G and 4G, it's multi-radio access for licensed and unlicensed technologies, including Wi-Fi. Maybe you want to complete this answer?
So as indicated, yes. So the 5G architecture is such that 4G, 5G, and 802.11 technologies can also all interface to the new core 5G core network.
Hi, Dorothy. I'm sorry, but you're cutting out, so I'm going to go on to the next question and impose that to Laurent or Olivier. Will the market for 5G backhaul services be similar as it is for 4G?
The market for backhaul, I'm not sure I understand the question. Can you repeat, please?
Sure. Will the market for 5G backhaul services be similar as it is for 4G?
I can take this one, Laurent. This is not an easy question, but I would say that the market will be bigger because it's not specific to 5G, but it's specific to the move towards cloudification of the RAN. So that means the RAN will be much more distributed in the future than the, let's say, the current classical BTS architecture of the RAN, and so it will generate much more backhauling, fronthauling needs, and so more market for that backhauling function. This is my view.
Great, thank you. Another question. Do the U.S. mobile operators, if you are aware of the carriers, actually have 5G base on the 3GPP standards?
Yes.
Yes.
Great, thank you. I know we talked a little bit about the service-based architecture. I wanted to ask what is a service-based architecture, if you could define that for our participants.
Yes, I will try to summarize that. The idea of service-based architecture is potentially each function could talk to all the other functions. Practically, it's not the case because there are principles and there are elements exchanged, but potentially it really opens the 5G core to network exposure functions and new functions. If a function or a third-party application is authorized, then this application is authorized to access to other elements in the 5G core, which was not the case or much less open in the previous generation. So that the idea of service-based architecture, potentially all functions can communicate together.
Thank you. Can you also elaborate more on how LTE and Wi-Fi connectivity are combined in your slide number 13? It's also a two-part question. Which situations would this combination be used?
In many situations where you want to have more bandwidth, or you want to have more reliability with the capability to be connected to two G.B, two 5G BTSs at the same time. This is already the case with 4G, where if you look at different smartphones, you do not have the same capability for the bandwidth because you do not have the same carrier aggregation. And if you take the idea of carrier aggregation with two different radio access type, then you've got the multiple connectivity. For more details, I think you will have to take the course because there are more details in 3GPP and in these courses.
Very good, thank you. Here's another question. Along with theoretical courses, is there a way to do some hands-on training on 5G using emulators in a classroom or lab environment?
Be happy to invite you to our Nokia 5G labs and training. So for that, we used to deliver training to our customers. So this is not so easy to come as an individual for that, but for those who are customers of Nokia, we will be happy to welcome you in our labs and to deliver training on real equipment on 5G. So I've seen some from Verizon or AT&T in the attendance. So if you will be welcome for that.
Thank you. Another question. IoT will have millions or perhaps billions of devices. What are the three top challenges to 5G technology in managing the communications?
You want to take this one or?
Maybe we can work the two of us. Three top things, I'm not sure I've got three in mind. The connectivity density, of course, is a real challenge. And for this, 5G will have some solution. I say will have because currently IoT is a part of 5G where the standard is less mature than for the other areas. So for me, the connection density is one key pillar and one real challenge, and the power consumption and power saving is another one. To have some devices with self-powered, with some batteries that could last 10 or 15 years. Olivier, I don't know if you want to add something on top of this.
Yes, you're completely right, and the difficulty is to manage the diversity of communication. As you said, IoT could be that there will be a lot of IoTs, and some will be camera with high definition, so where they need high bandwidth. Some will be sensors sending very few information. Some are sensors that we want to stay there for years, and so the communication style, and depending on what we expect from the IoTs, we need a different mode of communication and connection to the network, because if you constantly are triggered by the network to send signalization, then it doesn't fit with what you expect from your IoT. So depending on this type of communication and types of IoTs, we need a different slice from the network.
Great, thank you very much. I take a couple more questions. Do you believe the health concerns surrounding 5G are exaggerated, or are they a real concern?
I would tend to differ to what exists. So there is a literature today, so I know there are some concerns in various countries, but there are also some studies that have been made in Australia. So I don't have that in hands, but I know there is a very good study in Australia to share what are the impacts. And Australia decided to launch the 5G network in their country. So I would refer to the literature existing on that topic.
Okay, thank you. Another question that came in, and I thought I would pose, since 5G core is cloud native, can you elaborate if current implementations use private versus public cloud? Again, I'll read that again. Since 5G core is cloud native, can you elaborate if current implementations use private versus public cloud? And is there a common trend, what runs on public versus private cloud?
I think we have to differentiate what is a 5G core functions and what are the 5G end user applications. For the end user applications, that can be on both private, public cloud, or hybrid. For the 5G core functions, for me, it's not really a question of private or hybrid or public cloud. That's a question of quality of service and service level agreement. I don't think it's really a good idea to put 5G core functions in the public cloud, because by nature in the public cloud that's very difficult. It's like public internet. You cannot really guarantee your service level agreements. And that's why for me so far the 5G core cloud native with main CSP operators are still private clouds. But I have to say that I'm not subject matter expert with the cloud and cloud implementations. So that's my idea as of today.
Okay, thank you. I think that at this point that we'll, those are all the questions that we're able to take at this time. I want to just a reminder that there will be the on-demand will be available at least 2 hours after the event. And before you leave, please don't forget to complete our feedback survey via the tool. It's in the teal bar at the bottom of your screen. Also, I'd like to mention that our next event, which is Organizing STEM Activities, a Guide to Try Engineering Lesson Plan, will take place on March 25th, and you can register via the link in our resource list. And at this time, I want to thank our presenters very much so for your time and your efforts in putting together your presentations, and also to the group for joining us today. So I wish you all a great rest of the afternoon or rest of the day where you are globally. Thank you.
Thank you.
Thank you.